Right, well, having taken the Harrier CBHQ off the bench, we'll do a scratchy corner test on that later on, and then get it back to the customer tomorrow, who can then get it back to his customer. We've got the next one. Amstrad 901. No sound from speaker. Or headphones, not sure about headphones. Plug in the mic, just a bit of a crackle. When you try to transmit, the TX-RX lights, but power transmits lights don't light up, they don't flicker. And he suspects it's not receiving or transmitting. Clearly been worked on before. New Romney, Kent. Right. So we've got a genuine made in Japan Amstrad. I would still do the fake ones. I'll tell you what, the fake ones work better than a lot of the new radios of today. Well, you know, I'll tell you what, at least it's got a bit of a power plug. It's got a nice dent. Right. And at the moment we've got a realistic 1005 after this. And then hopefully we can get onto some of my own jobs. Because I know you're all dying to see some of these jobs of mine. Because I've heard people say, when are you doing this such and such? Well, I've got to do the customer jobs first. Right, did he say there was no sound from the speaker in his letter? So let's just see whether there is a speaker that actually does something. Yeah. We'll leave that handy because we'll need to do the VCO. So it's got the ballast resistor or dropper resistor, but it's been linked out. So that means it's going to be producing more power on aircraft band than it is on 27 megs. I keep saying this. When you put this on the spectrum analyzer, the last one we looked at, it did 2.7 watts on 27 megs, and it did 4 point something watts on 112 megs aircraft band. Because when you're using a cheap power meter to look at it, like those Zitagi ones, which read really fast, like our 4 watts equals Zitagi 7 watts, they're not selective. They're going to read everything power-wise within their range. And if you've got one which will cover, you know, 25 megs to 150 megs or something like that, it's going to just read whatever this radio gives, including all the spurious emissions, as power. So it just neatly adds it all up, doesn't it? So I'm doing 7 watts. Wow, really good I am. But you're not. You're doing, like the last one, 2.7 watts, and the rest on aircraft band. And that's when you start attracting the government inspectors. So yeah, it's when that's why I started doing these videos. When we were doing UK legal CB radios since it became legal in '81. And then 2014, I got so fed up looking at some of these ridiculous YouTube videos of people doing the most bizarre and daft things, legality aside. I thought, no, we'll show people on real instruments with real service manuals. Right, having picked my glasses back up off the floor. Well, I'll leave the link in, and then we'll... Yeah. Well, of course, they've had to change the transistor, haven't they? Because that will have burnt out because of the stupid modification. It's probably burnt out again. And where do we get that from? Because I'll tell you what, all the 2SC2166s which are kicking around on eBay and that, they're all fake. Because they stopped making them 20-something years ago. So how can they be advertised and be nice and shiny? Because they'd be really tarnished now if they were real. Okay, so what have we got connected to where? I think I borrowed the power lead, didn't I, for something the other day. Right, I'll pause the video while we get the power lead back. Okay, so we're now connected up. So if we switch the Roger Bleep off and go to channel 20 and there's absolutely nothing as you mind you, there won't be anything, will there, because we're not plugged into the extension speaker, but there's still nothing. So if we press transmit, goes into transmit and does nothing. There's no difference in current consumption on my power supply. So here's the first thing to do, see whether it works in PA mode. I suspect it's been reverse polarity, and if it has, then the LED driver BA656 for the bar graph display will have been destroyed, and so will the audio chip, which will be why there's no receive audio. So I've now switched it to public address, and hey presto, hello, nothing. So the public address isn't working. So until public address is working, that'll be, you can hear a power click. If I put my finger on any of the pins of the audio IC, there's nothing. So I suspect that the audio IC has a nice hole in it, and I also suspect that the protection diode isn't working. It doesn't look like it's not there. Right, we'll do some looking into it and I'll go back on to here later. Here's the clever bit of diagnosis with the audio chip now removed. I've got the audio chip out there. I can't see any damage to that. Normally you can see a hole in it. When you're mounting these on the heatsink and it goes in like that, it's the writing to the back. So pin 1 is to the right, indicated by the pip. So we'll unpack a new IC, and these are a small fortune these days. I don't expect it's a real genuine one. No. Doesn't say Sanyo on it, so it won't be a real genuine one. So this is what I was going to say. So putting this radio back to CB mode, I've got my little capo handheld here. We'll put that on channel 20. Now I've checked the VCO. So on receive, channel 20, we've got 3 volts. And on transmit, we've got 2.5 volts. So we know it's in lock somewhere. Now if we turn the volume up on this radio and have the area real close to the radio, hello, testing 1, 2. So the radio is actually generating the frequency, so the synthesizer is working, and I expect we've got a multiple fault we're going to have no bar graph because the display driver chip's being destroyed because of reverse polarity, and we're going to have no PA because I expect the output transistors no doubt knackered because of the stupid link underneath. Got fed up of talking on aircraft band. So we'll start by putting that audio chip in. If this was a made in Hong Kong set, I would say, are you sure you want to do this? Okay, so we now put the new audio IC. You can see that's the old one because it's genuine Sanyo one, and it's got the tarnishing of 38 years of being in the radio, but no holes in it. So they're an LA4422 for those who want to know. So we're still in public address mode, which is always a clever way to test sets when. So we'll give it some volume. Testing 1 2, testing 1 2, testing 1 2 3 4 5 5 4 3 2 1. So it now works in public address mode. So that's what we wanted to hear. It's quite a relief sometimes when sets have PA, because by the time you've done that, you've got about a fifth of the radio working. So have we got any FM noise? You know what, we haven't. Well, it can take out the subsystem chip, the LA1230. So the fact that we've got no receive that I can hear, just get that little walkie-talkie back. Nothing's happening, we're not receiving anything. So we know the synthesizer is generating the frequency, but we can't hear anything. So you know what? That LA1230 IF subsystem chip will have been fried as well. So I'll go and look for one. Right, that's the last LA1230 we've got, and that's the one we took out. And there is a tiny crack on the underside just there. So it's a genuine Sanyo one which has gone in, so that's our last one. I think these have gone up so much we're only buying them 2 at a time these days. Yep, so we've got an FM hiss. So we'll turn back to our receiver, our little walkie-talkie. Testing 1 2 3 4 5 5 4 3 2 1. So now the radio is receiving. So we'll put the signal generator on. Now, I haven't bothered putting an error in yet because we know it wasn't transmitting because of its. Why are we getting a short circuit when I plug the error in? Oh. So there's something happening causing the audio to go down to earth, and this could have been what's killed it. So it's either there could be dodgy wiring round there or something else. So the chassis doesn't appear to be floating anymore. So if we go to the on and off switch, we should have rail voltage, which is 13.6, and to the chassis we shouldn't, but we have. The metal chassis has become earthed somehow, so we've got to look into that and see what's happened. I can't progress any further without that being right. And I didn't miss the insulation kit off that. Just make sure that there isn't a puncture. So going between chassis and the fin of the audio IC, we shouldn't have. We've got 100 ohms, but we shouldn't have a short, whereas we have to the chassis. That should be alright. That's going to take some tracking down. What fun. But back to the other thing. I'll go back to using the, well, I can plug the signal generator in, because I can't plug the signal generator in. I'll tell you what, we can put it on. Oh. It'll do that. But it's easier to do it with this. So, if I key up and we can hear the radio, we have no bar graph. So the display chip is knackered. Now, is that causing the short? The internal short on that could be the reason we've got a chassis short. So I may as well change that, and that is just there. So it's quite difficult to get to. So we'll unsolder it, and whilst I was looking through the parts bin, I got the packet of replacements out. I think I'm sure there is an NEC device. When I was at Nottingham Radio and fitted mobile car phones, cellular car phones, the first generation of analog ones were just coming out in very late 80s, you know, like 1989, and were thousands of pounds each. A young lady came round as a rep for a company who did these things, who were at Birmingham. And so she sat down in the kind of officey area we had, and I came off the workbench, because I may have been service manager there, but I was hands-on. And she said, "See, we've got our own make." And she pulled this car phone out. It said NEC on it. I said, "I thought you were National Executive Car Phones," or whatever she was called. She says, "Yeah, that's right, NEC." I says, "Well, obviously you've been told to say this, but NEC is Nippon Electric Company." So I said, "Well, if I were you, I'd resign your job because you're being told bull." Anyway, I'll pause the video while we pull that chip out. Well, we found a short circuit. The output transistor's been changed without an insulating kit. So if I touch the meter onto chassis, so we get a continuity. If I now go onto the tab of the device, and of course it should be isolated from chassis. Oh dear, oh dear, oh dear. So behind the scenes we've been working on this set. What we've done in discussion with the owner is the only way out of this output transistor problem is to put something in off a scrap chassis. The customer's spending a lot of money fixing this, and he doesn't really want to be spending another £15 on an output transistor that actually will help develop 4 watts. As I've said many times before, nearly every 2SC2166 transistor on the market is fake, and even I've bought fake ones, and it's just a waste of money. The Eliflow ones seem to be okay, but you know, Mitsubishi stopped making these transistors 20 years ago, so you can't possibly be getting nice, shiny, bright, gleaming ones, and this is what's happening. So they're clearly, when you look at the gain on them, you look normally on these type of transistors, you're looking at about between 17 and 30 something for the gain. And you put one of these fake ones on your tester and it says 178 gain. Well, it can't be, you know. So, and you put them in and you get 100 milliwatts if you're lucky, and they get red hot. So this is the problem. So I managed to find a 2SC 1969 which works on a scrap chassis. I did try a 2SC 2075, and I didn't really get above 1.5 watts on that. So we've got approaching. I'll just switch over to the other scale. We've got approaching 3 watts. And remember, that's 3 of our watts. So we've got 2.5 of our watts now on this radio. It's gone the other scale. Oh well, I'm on the wrong one. Gone the wrong scale. It shows just over 2 watts on that one. So the radio is going to work, and it isn't. I don't think it's going to affect the range that much. But the only way out of it is to spend 15 quid on the right transistor. So at least it works. So I'm not going to show you the tuning of this because I've done it meticulously in order to do that. So we've done. I can't even remember if we did the VCO on this. I really can't remember where we got to because it's some days ago and I've done a lot of things in between. But I'm just going to check that we've got something like you'd expect on the VCO. So just pop it onto channel 40. I'm sure we must have done. Yep. Yeah, we've got the kind of voltage you'd expect. So to recap, we've done the audio IC, the subsystem IC, LA1230, LA4422, BA656, bargraph display driver, and then of course the output transistor, and we've put a new ballast resistor or drop resistor, whatever you want to call it, in there. So we have got some RF power. So we're going to still set this as if it's 4 watts. It's booming across, even though it isn't. We'll just set that up. So we want it on 4 lights, don't we? We don't want it to be getting that excited. Then on low power, we're doing 360 milliwatts. So it's about where it should be on low power. Deviation, let's have a look at that. Wallow. Well, I haven't got any at the moment. Are we tuned in? Wallow. We're not tuned in. So, where's my little oscillator? But that's ruffling the microphone somewhat. Wallow. Wallow. Exactly as it should be. That must have been about 5. Ridiculous. So that's covered the transmit. So let's go on to the receive. Just make sure the signal generator is on frequency. Oh, we haven't put the radio on frequency. Let's do that. Just change the camera back to, which is where we started, because that's what I intended doing. Let's see how close we can get it to 27.79125. Well, that's something that's gone right. And back to doing the receiver. Right, let's see where we are. We are plugged in. I will just show you how, by the way, before we go out of transmit totally, I did have this on the spectrum analyzer to make sure that, let's put that somewhere near, that we've got what we're expecting, and we have. I didn't want half of it coming out on aircraft band. So what are we listening to? That's full whack. 1 microvolt. It's going to be good on receive, this. So we'll start by putting the oscilloscope on the screen. Turn the bench lights off. Switch that to S9. So we've got 100 microvolts being presented to the receiver. We just want to make sure that we have optimum. Air conditioner's just come in again. We have optimum recovered audio from the detector. It's that down there, isn't it, on these sets? I think that was more or less spot on. Let's go over to the cyanide meter. Go through the front end. The bottom core down there is broken, so we'll see what we can find on our scrap chassis. I'm going to have to stop charging him for anything because it's just gone stupid. We're even reducing our fee because of that. So this scrap chassis is a genuine Japan. Can't say. Look what someone's done to the PA on that one. That's why it's a scrap set. But I think this is the one we've had the transistor out of. I'll pause the video and get that off. So back on record, and we've changed that to that scrap one. So hopefully this one will adjust. There we go. Right, I reckon that's it. Just check those front end ones once again, I think. See where we are. So for 12 decibel cyanide, we've got 0.27 microvolts. So that's fine. That's where we want it to be. Right. I think we're just check the S meter then. So it's banging across to plus 30, which isn't very useful. That's now there. We can increase that to plus 30 with a plus 30 signal. And we just need to set the squelch, which is the letdown on this chassis usually. So we're going to turn the squelch to full and advance the signal generator to 100 microvolts. 1, 3, 10, 30, 100. I want it to come in at 100. It isn't doing. It is now. I want it to be off at 30 and it isn't. In at 100, off at 30. That's where I want it. So now we'll turn the signal generator back to 0.3 of a microvolt and switch the signal generator to standby. Set the squelch threshold to... There we go, that's threshold. Switch the signal generator back on. It's come straight in. It's coming in at 0.33 microvolt and it's leaving us at 1.7, so it's actually better than a lot of these. Did I say that wrongly? I did. It's coming in at 0.33 of a microvolt. It's leaving it 0.17, not 1.7. So there we go, we've actually done it. See how that works on scratchy corner, just approaching 3 watts. And this is all caused, all those chips were caused by the reverse polarity wally. See, the first time they do it, they blow the fuse in the thing, get rid of the fuse. Next time they do it, they blow the diode. Then the next time they do it, they blow the radio. And coupled with the fact that there was no transmit because the ballast resistor had been bypassed, it's unbelievable that people are killing those transistors. And a quick look on YouTube at some of the ridiculous modifications. And it's actually, that's why we started this channel in the first place, because it was so full of bull about CB radios, and we've been servicing them in a professional field, starting when I was at Nottingham Radio, really on a commercial basis, and it's just unbelievable. So I think we'll just pop that on the aerial. I think the problem with the Amstrad in general was that it's kind of being looked down upon because of all the fake ones. Oh, it's only an Amstrad, you know, and this is an £89.99 set. It's not the £29.99 fake one, you know. This is the trouble. So let's see what we've got. Nineteen Roger. Roger. Well, there was a bit of life out there. So before I put the cases on, I've just run over this with isopropyl alcohol, and I mean, I don't know how many transistors this has had in the past with the silly modification, but anyway, clean that up. We'll change the BA656 there, LA1230 there, and LA4422 there. So if I can remember where I put the cases, let's hope his speaker works. Normally I disconnect these. Got it in the right twazzle. So there we have it, back together, ready for the scratchy corner test. So thank you for watching the extensive repair to the Amstrad CB901, genuine Japanese one from 1981.